The AI team at Qwen has been on an absolute tear lately, just dropping new models so fast it's almost impossible to keep up. But today, we're digging into something really different. It's a fascinating new model called Qwen3 Next. And get this, it wasn't even a planned release. It was an internal experiment that turned out so well, they just had to share it with the world. And believe me, it pretty much breaks all the rules.
And that brings us to this central paradox, this riddle. How can an AI model be a massive 80 billion parameter giant, but at the exact same time, operate like a tiny, nimble 3 billion parameter model? It sounds completely impossible, right? Well, that is the mystery we are going to unravel right now. Okay, let's just dive right in. The first thing you've got to understand is that Qwen3 Next is basically a research preview. It's like they're pulling back the curtain and giving us a peek at their internal R&D. And this little experiment could seriously shake up not just their own models, but the entire field. So what were they trying to do here? Well, the goal was really two things. First, they wanted to figure out how to train these huge models way, way faster and cheaper. And second, they wanted that efficiency to trickle down to you, the user, giving us AI that's not just quicker on its feet, but smarter too. So let's get back to that crazy puzzle about its size. To really get how it can be both enormous and tiny, we've got to look at the actual numbers. First, let's just talk about raw scale. The model has a staggering 80 billion total parameters. Now, you can think of parameters as kind of like the neurons in a brain. This number is its entire library of knowledge, its total potential, and it puts it squarely in the heavyweight class of models. It's a monster. But here's where it gets wild. For any single task you give it, what we call inference, the model only lights up 3 billion of those parameters. That is a tiny, tiny fraction of its total brain. To put that in perspective, that's about the same number of active neurons as their much smaller models, but it has this vastly larger library of knowledge to pull from. So let's put a number on that. A mere 3.7% of its brain is active at any given moment. This is what's called extreme sparsity. It's like having the entire Library of Congress in your head, but being able to instantly find the one perfect sentence from a single book for any question you're asked. This radical efficiency is the absolute secret sauce here. So the crucial question is, how on earth do they pull this off? It's not magic, I promise. It all comes down to 3 key technological breakthroughs that Qwen is playing with. So these 3 innovations are hybrid attention, extreme sparsity, which they do with something called a mixture of experts, and multi-token prediction. Let's just quickly unpack the 2 that are really the game changers here. Okay, first up is extreme sparsity, using that mixture of experts idea, or MOE. Think of it like this. Instead of having one single generalist trying to know everything about everything, this model has a huge board of specialized consultants. So for any problem you throw at it, it just routes the question to the 2 or 3 most relevant experts. It makes the whole process incredibly efficient. Now, what's really nuts, and what you can see here, is the sheer scale of that specialization. Qwen3 Next has 512 of these distinct experts. That is 4 times the number of experts in their own previous models and other big open source models. This huge increase lets every part of the AI become hyper-specialized at what it does. The second massive innovation is something called multi-token prediction. Okay, so most AI models generate text one single word piece at a time. It's slow. Qwen3 Next is designed to predict and spit out whole chunks of text all at once. This makes a radical difference in how fast you get a response, and it makes the whole experience feel so much more natural. Okay, so all this tech sounds cool, right? But does it actually work? Let's see how these innovations really translate into real-world performance. Does this experimental model actually hold its own against the big guys? So if we look at the benchmarks, yeah, the much, much larger 235 billion parameter model still wins. No big surprise there. But what is surprising is how incredibly close Qwen3 Next gets while using just a fraction of the active brain power. It's even outperforming other models that were trained on twice the amount of data. And this right here is the real breakthrough, the efficiency. Qwen3 Next gets these amazing results for less than 10% of the training cost of some of their other powerful models. I mean, this just makes state-of-the-art AI dramatically cheaper and faster to build. It's a game changer. And what's even crazier is the untapped potential here. The team got these results using only 15 trillion tokens of data out of a possible 36 trillion they had waiting. So it did all this on less than half of its available training fuel. Imagine what the next version of this could do. It's just wow.
So what does all this mean for you as a user and for the bigger AI world out there? Well, the implications are actually pretty huge.
For you and me, the most immediate thing you'll feel is the speed. That multi-token prediction we talked about, it means information just streams in these fast, natural-feeling chunks. It feels less like a machine typing at you and a lot more like a fluid conversation.
And when you actually play with it, you find some other cool, quirky things. For example, you can ask it to respond in, say, Thai or Chinese, and you can actually see its internal thought process happening in English before it gives you the final answer. It's like a cool little peek inside the model's brain.
And strategically, this release changes the entire game. By openly sharing such a powerful and efficient experiment, Qwen is putting immense pressure on its competitors, especially in the open source world like Meta. The pace of innovation is accelerating like crazy, and now everyone else has to keep up. Which really leaves us with this one final crucial question to think about. In a world where these nimble, open experiments can start to challenge the super expensive closed-off models, who is really going to define the future of artificial intelligence? It's a whole new ballgame.